I am Fabien Zulim, the senior author of the paper entitled Quantification of Circulating HBV RNA expressed from intrahepatic cccDNA in untreated and nucleoside analog treated patients with chronic hepatitis B, which was published recently in Gut by Barbara Testoni and collaborators. Today, major efforts are ongoing to develop novel curative strategies to treat chronic hepatitis B. Their objective is to achieve a loss of serum HBs antigen, also defined as a cure of the infection, with two different levels: a complete HBV cure defined by the clearance of cccDNA from the liver, and a functional cure, which is defined by a transcriptional silencing of cccDNA. Thus, it is critical to assess both the cccDNA amount and the cccDNA transcriptional activity defined by the ratio of the 3.5 kb-RNA over cccDNA. However, there are limitations of this approach, with the need for a liver biopsy, the potential issue with tissue sampling bias due to the heterogeneity of the virus in the liver, and technical challenges for the quantification of cccDNA. Thus, there is an emerging need for non-invasive biomarkers reflecting the intrahepatic cccDNA pool and transcriptional activity. Among the approved and investigational biomarkers, the quantification of circulating HBV RNA has emerged as a promising biomarker of the pool of transcriptionally active cccDNA in the liver. Thus, the aim of our study was to investigate the biological and clinical relevance of the biomarker with a novel assay. This is a collaborative study between the viral hepatitis unit of the Lyon Hepatology Institute, the Hepatogastroenterology Department of the Milan University Hospital, and Roche Molecular System in the frame of a grant from the French National Research Agency. A diversity of viral RNA is found in the blood circulation. They circulate in different types of viral particles and even in exosomes. The viral transcripts derived from cccDNA comprise a canonical polyadenylation signal, while the transcripts derived from HBV integrated sequences use either a cryptic or the host polyadenylation signal. The prototype assay used in this study targets the 3' end of the viral transcripts and amplify the HBV transcripts containing the canonical polyadenylation signal. Its performance was described recently. In this study, using hepatoma cell lines harboring naturally integrated viral sequences, we further show that this assay preferentially detects cccDNA derived transcript, but not from integration. We assess the relevance of the biomarker and the performance of the assay in a unique clinical cohort of chronic hepatitis B patients who had paired liver biopsies and blood samples. The cohort consisted of 122 untreated chronic hepatitis B, with a majority of HB antigen negative patients and HBV genotype A or D, and a group of 25 NUC-treated chronic hepatitis B patients, virally suppressed, that were eligible for liver transplantation. Most of them were cirrhotics with or without hepatocellular carcinoma. The analyses were performed in the native liver and blood sample at the time of liver transplantation. In HB antigen negative untreated patients, our analysis showed that the absence of correlation of circulating viral RNA with cccDNA in the liver, but a significant correlation with the expression of 3.5 kb-RNA and cccDNA transcriptional activity in the liver. The correlation with serum biomarkers showed a strong correlation with serum HBV DNA and HBc-related antigen, but no correlation with HBs antigen, which is consistent with the fact that in these patients, HBs antigen is mainly expressed from integrated sequences. We next investigated the correlation between cirB-RNA and HBc-related antigen detectability and cccDNA amount and transcriptional activity. The results showed that in both untreated patients and NUC-treated patients, the detection of both biomarker is significantly correlated with higher cccDNA transcriptional activity. Altogether, our study describes the performance of a new automated prototype assay for the quantification of serum HBV RNA, which preferentially detects viral RNA derived from cccDNA versus untreated sequences. Our study provides new information on a new non-invasive, robust, and reproducible diagnostic tool, which will allow to assess the transcriptionally active intrahepatic cccDNA pool in untreated and NUC-treated patients that will be useful to guide treatment cessation and monitor intrahepatic viral clearance. The next step will be to demonstrate its clinical utility by assessing target engagement in early phase clinical trials with novel antivirals, by demonstrating its predictive value for functional cure and for the monitoring of untreated patients. I would like to thank again all the authors of this collaborative research, and if you need more information, do not hesitate to contact us at the Lyon Hepatology Institute.